Okay, last lesson we did this, where you were representing linear relationships with a table. That's all well and good, quite understandable from you people because you answered that very quickly. But that's not the ideal way to show a linear relationship, because if you have a lot of data, what's that table going to look like? That table is going to take up the whole page or more, okay? A better way of expressing a linear relationship is with a linear function or equation, and you really should have seen this in previous years. Last year, I'll bet my sneaker collection that I taught you this for the mainstreamers and the ignites. You other people, I don't know. Depends on your teacher. So hopefully you've seen the equation of a line in slope-intercept form is y is equal to mx plus c. But I'm going to go into detail about what those things mean in my own way, because the people that I haven't taught, have you heard of the term rise over run before? Does that ring a bell? Mm-hmm. That's what I encounter that a lot of teachers teach it as, but I don't like that, because rise over run suggests that lines always rise. They don't. And run what direction? So I'm going to break it down a bit more, less airy-fairy. So again, equation of a line in slope-intercept form is y is equal to mx plus c. What does y stand for? It's the value of the y coordinate. X is the value of the x coordinate. But this is where I'm going to add my own 2 cents. M is the slope of the line. You should write it as a fraction, because when you write it as a fraction, the top of the fraction tells you the step up or down, and the bottom of the fraction tells you the horizontal step to the right of your linear relationship. And then C is the y-intercept or starting value of y. Can you get that box down, please? That could go on your cheat sheet. The only other thing we do today is an example. So a few minutes. Just need to check the tabs. So the purpose of doing the algebra is, instead of having a table that goes on forever, you can state the linear relationship with 1, 2, 3, 4, 5. You can state the linear relationship with 6 characters, and it'll always work. So you can see I'm chucking a little bit of algebra into your realistic context, because that's what mostly you're going to be doing in your exam. Most of the marks associated with it are getting some real situation to look like this. Why is the equation of a line useful? Because it literally just tells you mathematically what happens to x to make a certain y. So for example, if my equation was y is equal to 2x plus 3, what's that telling you? Y is always double x, add 3 to the answer. Right? So if we see this situation here, I know it's contrived, but that's a semi-realistic scenario. The amount of water in a horse trough over time is given by the table of values below. Starting at time 0, going up in 2s. Volume of water going up, so they're filling up the horse trough. The lesson blanks are on Damo, as far as I remember. What is the y-intercept? What is the starting value of the volume of water? Looking at that table, what did the horse trough start at? Did it start off at 0?
No.
What did it start at?
30.
Yeah. Boys, you came in late. Don't talk. Please don't lose a mark to that. You're just reading it off the table. Litres. What is the slope? This is where you need to think. What is the slope of the linear relationship? Well, here, the slope is the vertical step up or down over the horizontal step to the right. So, x is your time, y is your volume. How much is x going up by each step? 2. So it's going up plus 2, plus 2. What is the volume going up by each time?
Plus 20.
Plus 20. And we just established that the slope is the y step, which you just told me was plus 20, over the x step, which was plus 2. What's 20 divided by 2? 10. So the slope is just 10. Why is that useful? Why is it useful for me to find the y-intercept and the slope? Well, I can write the equation of the line straight up, because the equation of the line is y is equal to mx plus c. M is the slope. C is the y-intercept. So replace those things with the info that I've got. Y equals, what did we just work out the slope was? 10. 10x plus, what did we just work out what the y-intercept was? Say it louder. 30. Almost there. You don't have full marks yet, because using the info from A and B, state the equation of the line in terms of t and v. We don't want it in terms of y and x. We want it in terms of t and v. So volume is y equals 10, x is the time, plus 30. So now we have the equation of that line in context of the problem, which was volume and time in minutes. Last 2 questions here. Find the volume of water after 6.5 minutes. Does the table have 6.5 minutes in it? No. I could fill it in, but the point of doing the algebra is we can just replace the algebra. Find the volume of water. Volume equals 10. What would T be if it was 6.5 minutes? 6.5. So 10 times by 6.5 plus, what does the equation say? Plus 30. So volume is going to be, what's 10 lots of 6.5? That's going to be 65 plus 30. 65 and 30, 95. There's going to be 95 litres of water after 6.5 minutes. Why did we get that fast? Because we developed the equation and I didn't need to fill in this table to find 6.5. Possibly the hardest maths you have to do in this topic is E, where you're rearranging the equation to find y. Okay? It tells me how long would it take to reach 160 litres. So in my equation, I know the volume is 160 is equal to 10 lots of T, I don't know the time, plus 30. He's saying it, but how do I get T by itself? What are we doing with that 30? I'm adding 30. What's the opposite of adding 30? Subtract 30 from both sides. I'm going to write it in a little brick there. If I've taken 30 from both sides, is there going to be a 30 left on the right-hand side anymore? What's going to be left on the right-hand side? 10t. 10t equals, what's 160 take 30? 130. What's that 10 doing to t? So the opposite of timesing by 10 is dividing by 10. Divide both sides by 10. So t is going to be 1.3.
It's the
13, sorry. 13 minutes. Good catch. So you can see our table doesn't contain 160 litres. We could have extended it if we wanted to, but that's a waste of time. We've got the equation here. Could we use that equation to work out the volume after a bajillion minutes?
probably.
Just replace t with a bajillion and you'll get your answer, okay? So your only work today is 12 answers, questions 1, 3 and 5. Catch up anything that you haven't done yet and you may chat.